Alright, now we will talk about the on-off and direction control of a three-phase motor. Okay, so we have the same latching circuit here as well. Now for direction control, the simple method is when you interchange the polarity of the phases. Like if I'm giving L1, L2, L3 in a sequence to, let's say if it is U, V, W, if I interchange L2 and L3, if I give L3 to this V and L2 to the W, then the direction will be changed. So how we can do that using a relay and contactor circuit? Let's see that. So initially what I will do is I will use a contactor 2 to provide the main supply. That will be the main on-off. So in that case I will copy paste the 3 contacts, and to remove this tag contactor 2 because it's taking a lot of space, I will just remove its display, but you can understand that this is contactor. This is a part of this contactor too. Okay, so I'm going to connect this here, here and here. So this is the main contactor. Now it's up to you if you want to use the main contactor for main on-off, but I recommend you. So you use this 3 contacts just to have the main supply from this point to this point. Okay, just from here to here. Now we will define a circuit which will interchange the polarities. Okay, so let's take the example if you want to change the direction using push buttons. So these simple push buttons. So what I will do is I will take it here. Oh, wait a second. So I will copy paste this switch, but in your case you have to take a new switch. You have this switch, let's name it as not A but forward, or in direction 1. So you will use this switch and you will connect another contactor, and let's name it as forward in series to this switch. Okay, and this will be connected here, 0 volt, considering that this contactor is also working on 24 volts. And similarly we will latch this contactor. Let me just utilize the space properly, and we will take a contact, normally open. We will tag it with forward. Okay, now in this example we are going to interlock the directions. Okay, if it's running in one direction, we have to run it in another direction. We have to make an interlock circuit, because if you press both buttons, that will be a problem. Okay, so to make interlock circuit, first just make this this latching circuit, then I will show you how to introduce an interlock. So this is a forward, this is a latching of forward contactor. Okay, so you take these coils here and connect like this. So the first phase I'm connecting directly to, this is my U, so I can even write here, this is U, that's V, and that's W. Okay, so this L1 is going to U directly via this contact. So the second one we will take directly to V. Okay, and third one directly to W. So we're using the same sequence, we haven't changed the sequence. This will run in one direction. So let's check that. So that's my main supply. My main supply is coming to the forward contactor, and then if I latch the forward, this is going to run in one direction. Okay, this is the same direction. Now I don't have any contact to stop this forward direction, so we have to include stop button as well. Okay, and one more thing, if I want this to run in another direction, we have to take contacts in parallel, which we haven't made yet. Okay, so let's first introduce the stop switch. Stop switch you can introduce here, or what you can do is you can just connect your stop switch, which was here, instead of here. You can keep it next to emergency. This will also work. So then this will be a stop switch for both the operations, for latching and for forward as well. So let's check that. This is main connections on, this is forward, this is stop switch. But if you want independent stop switch for on off and independent for forward, then you can keep that switch here and take another switch, connect it here. So you will have an independent on off operations. I can also show you that. So let me just undo the operations. This was here. We will take another stop switch here. And I will just rename it to X2. Okay, this is here, this X2 is here, this contactor is this part. So here we will see this is the main supply on, and this is the main supply off, okay? But here when you run the forward, and if you just want to turn off this forward, you turn off from here. This switch will not affect the main supply. Okay, this is forward latching, this is unlatching. This is main on, this is main off. But if you have forward on and latching on, but you want to turn off everything, then we have emergency to turn off everything. Now this circuit is much better. So it depends upon you where you use your NC switches, it changes the operation of your circuit. Okay, so connection is very important. Now let's come to the reverse part. For that, I will again take another switch, modify it, name it as reverse, connect it here because everything is 24 volt. Then I will take another contactor, rename it to reverse, and connect it here. This is coming in parallel, and I will take another NO coil of this reverse, name it as target with reverse because this common in NO is of this reverse coil. Alright, so this is not complete yet, but we'll see what happens. Let me just zoom out a bit. Yeah, this is okay. I would just like to arrange it a little. Okay, so let's have a look to our circuit now. So this is the main supply, this is on, and this main is off. This is working perfect. Now this is the forward. This is running in one direction, okay? So now we have to connect, this is reverse is latching. Now we have to connect the contacts to make it in reverse direction. So in that case, we will copy these contacts, and first phase we will go as it is because first phase we are not going to change. U phase is going to be same. We just have to interchange these phases. Okay, so this forward was here. Now I will take another contact. This is getting L2, but this L2 will not go to U, but this L2 will go to W. Okay, this is how you can connect. Another one, reverse. This was forward. Reverse is getting L3, but L3 will not go here, but this will go here. Okay, this is how you interchange the phase sequence. Now let's see, this is going for main. This is in one direction. You stop it. This is in another direction. Now you will notice that this is the L2 coming in the second line, but this red line is going here to the W, and this blue is coming from here going to V. And if you see the forward, this is the same sequence. So we have interchanged the sequence here. Now what will happen if I press forward reverse together in this circuit, because we haven't introduced the interlock? This is going to damage the motor, and this will going to blow up this overload relays as well, because the phases will be in touch. So this is a simulation, we can try that. So if I press this button, you will notice these phases are matching, and this is a dangerous situation. We should avoid it using an interlock, because you can manually tell to the operator that do not press the switch together, but if he do by accident, or I don't know, by any mistake, you have to prevent that. To prevent that mistake, we will introduce interlock. So what we will do, remove these lines from here. We will use the NC of this contactor forward in the stop operation of reverse, an NC of this reverse in the stop operation of forward. Let's see that this is an NC and one is forward. Now this symbol NC is also the symbol in relays. This is in conductor. So this is another part how to represent an NC. We have seen that this is a symbol for NO, and if you see this line, which means these parts are these terminals are connected together, which means it's NC. So one part is common, another part is NC. So this is a forward, so this comes here. I will show you how does it work, and then we will take another NC, name it as reverse, and connect it like this. Now you will notice the main is on. When I latch the forward, because this was the NC of forward, this is open. Now if I click reverse, nothing will happen, because this signal will not pass through forward, which is open, because this coil is latched. So this is how you introduce interlock. Okay, now I can only run forward, I can only run reverse if I press the stop. Now when I press stop, this was off, and so this is closed. Now I can go to reverse. Even in this case, if I go to forward, because this reverse was latched, this is open, I cannot run forward. So I cannot run two things together. This will only allow me to either run it forward or reverse. So this will also, I can change the direction if I press stop and then I run forward. If I press both the buttons together, even then you will notice that the one which I pressed first was forward. Because of that, this is open, I cannot run reverse. So in either cases, if I press it together, my motor is safe. This is a kind of interlock we introduce. Okay, now in the next video we will see the interlock, which will be similar, which will be quite different from this interlock circuit, but that interlock we will use in case if you're using a limit switch to change the direction of motor. All right, let's see that in the next video, which is very interesting.